All right, let's work on these last couple examples here. We already went from scientific to standard. Now we need to know how to go from standard notation to scientific notation. So our first example is going to be 18,500,000. Okay, 18,500,000. That's our standard notation. Let's take that into scientific notation. So the first thing we need to do is decide where our decimal needs to end up, because remember that number, like over here, the number before the multiplication sign needs to be between 1 and 10. We wrote it up here. The number before the multiplication sign must be between 1 and 10. So where can we put the decimal here to make this 185 between 1 and 10? Well, if I put the decimal right here, that's 185. That's way too big. If I put the decimal here, that's 18.5. It's getting closer, but it's still too big. If I put the decimal here, that's between 1 and 10. 1.85 is bigger than 1 and less than 10. So that's where I want my decimal, is right after the 1 in this case. So I'm going to go ahead and just write that down here, 1.85, knowing that that's where I want the decimal to end up. All right, now I'm just going to make a little note of where I want that decimal to end up. Now we need to remember where the decimal actually is in this number. Okay, now ignore that because I just wrote it there. But in a whole big number like this, in a whole number, the decimal isn't always shown, but if it's not shown, it's at the very end of the number. Just like a period at the end of a sentence, if you don't see a decimal written in a number, it's at the end of the number like that. All right, so now what we need to do is count how many spaces between where the decimal is currently and where we need it to end up. So let's go ahead and count. And we're going to just go ahead and count. 1, 2, 3, 4, 5, 6, 7 spaces is how many it needed to move. Okay, so I'm just going to make a little note of that, 7 spaces. Now, so it's going to be times 10 to the 7, and we do need to decide, because remember, your exponent can be positive or negative. We need to make sure that this is supposed to be a positive exponent, or maybe it's supposed to be a negative exponent. The way that I always think about this is just think about where your standard notation number began. If it was a really big number, so if this scientific notation needs to represent a really big number, keep that a positive exponent. But if this is going to represent a really tiny number, a really big decimal number, that's when you would want a negative exponent. Okay? So in this case, 18 million is a pretty big number. 18,500,000 is a very big number. So this is representing a big number, so I want that positive exponent. So that ends up being our final answer. Let's look at one final example. And in this case, it's going to be 0 point, and then looks like there's 6 zeros. 1, 2, 3, 4, 5, 6, and then 185. All right. So again, same thing here. We need to look and decide where we want our decimal to end up. Well, this is pretty much the same thing as our previous example. If I put it back here, 185 is too big, 18.5 is too big, 1.85 is just right. So I'm going to rewrite 1.85 down here, and I know it has to be times 10 to some power, so let's figure that out. Decimal is already shown in this number, so in this case it's not starting at the end. Because it's already shown in the number, we're just going to leave its starting point right where it's already shown. Now we need our ending point to be right there to make it between 1 and 10. So let's count how many spaces are between there and there. So 1, 2, 3, 4, 5, 6, 7 spaces. This time, remember, this is a really tiny number, 0.000, all these zeros. This is a really tiny number. So we want our scientific notation to represent a really tiny number, which means we want a negative exponent this time. So 1.85 times 10 to the negative, we moved 7 spaces, so 10 to the negative 7. And that's our final answer. All right, so hopefully that makes sense. If you want some example problems, the ones we did in class were 0.5 4 zeros and then 115. And then our number 4 example was 509 million. It's a big number. And just like over here, we did scientific to standard. Over here, we're doing standard to scientific. You can label it that way if you want, just to be clear. All right. So hopefully all of that makes sense. If you have any questions, please feel free to ask. Good luck.